Have you ever wondered what happens when a massive interstellar object hurls through space at incredible speeds just close enough to Earth to disturb the delicate cosmic forces that keep our planet stable? What if right now, while you're listening to these peaceful words, 3I Atlas, the third confirmed visitor from another star system, is subtly pulling at Earth's gravitational field in ways that could be affecting everything from our ocean tides to the behavior of migrating animals? In 2024, as the Atlas telescope system tracked this ancient wanderer's approach, something unexpected began happening on Earth. Sensitive instruments around the globe started detecting minute but measurable changes in our planet's magnetic field strength. Weather stations reported unusual atmospheric pressure fluctuations. Marine biologists noticed subtle shifts in whale migration patterns along the Pacific coast. These weren't random coincidences. They were the first signs that 3I Atlas was reaching across the void of space to touch our world. And here's what makes this discovery truly remarkable. While 3I Atlas will make just one pass through our solar system before disappearing forever, its gravitational influence is creating a cascade of barely perceptible effects that are rippling through Earth's interconnected systems in ways we're only beginning to understand. Tonight, as you settle into this gentle exploration of cosmic forces, you'll discover how this interstellar messenger is temporarily reshaping the invisible forces that surround our planet, and why its brief visit might be leaving subtle fingerprints on Earth that could persist long after it's gone. Before we drift deeper into this celestial mystery, feel free to like, subscribe, and softly touch that notification bell if you find comfort in exploring how the cosmos gently influences our world. Right now, as 3I Atlas continues its high-speed journey through our solar system, Earth is experiencing something that hasn't happened since Comet Borisov's visit in 2019, the gravitational tug of an object that doesn't belong to our Sun's family. This ancient wanderer, despite being relatively small compared to planets, carries enough mass and velocity to create what astronomers call gravitational perturbations, tiny but measurable distortions in the fabric of space-time around our planet. Dr. Elena Vasquez at the Global Geomagnetic Monitoring Center was among the first to notice these subtle changes, working through quiet midnight hours, analyzing data streams from magnetometers positioned across 6 continents. She discovered that Earth's magnetic field was experiencing microfluctuations that coincided perfectly with 3I Atlas's closest approach trajectories. These weren't the familiar rhythms caused by solar wind or our moon's gravitational dance. They were something entirely new. The effects were almost impossibly delicate. Earth's magnetic field, which normally varies by several hundred nanotesla during typical space weather events, was showing variations of just 2 to 3 nanotesla that seemed to pulse in harmony with 3I Atlas's orbital mechanics. To put this in perspective, these changes were so minute that they could only be detected by our most sensitive scientific instruments. Yet they were consistent, measurable, and undeniably linked to our interstellar visitor's presence. What fascinated researchers most was how these magnetic field changes appeared to be influencing Earth's upper atmosphere, creating barely detectable ripples in the ionosphere that could potentially affect radio wave propagation and satellite communications in ways so subtle they might go unnoticed for months. As 3I Atlas draws gravitationally on our planet, Even at its vast distance, the effects cascade through Earth's interconnected systems, like gentle waves spreading across a cosmic pond. The object's influence extends far beyond simple magnetic field variations. It's creating what scientists are calling tidal resonance effects that are subtly altering the behavior of Earth's oceans, atmosphere, and even its rotation. Marine research stations along the California coast began reporting unusual patterns in tidal measurements that couldn't be explained by the familiar gravitational pull of our moon and sun. The differences were microscopic, variations of just millimeters in sea level, but they followed a precise pattern that matched 3I Atlas's approach vector. Dr. James Chen at the Pacific Oceanographic Institute spent weeks verifying these measurements, initially suspecting equipment malfunction before realizing they were witnessing something unprecedented. The interstellar visitor's gravitational influence was creating what he termed phantom tides, subtle water movements that occurred independently of lunar and solar cycles. These microtides were so gentle that they posed no threat to coastal areas, but they represented the first confirmed case of an interstellar object directly affecting Earth's hydrosphere. Ocean currents in the deep Pacific showed minute temperature variations, as if the planet's vast water masses were responding to gravitational forces that originated in the space between distant stars. Even more intriguingly, seismic monitoring stations began detecting what appeared to be extremely low-amplitude vibrations in Earth's crust. Not earthquakes, but rather a subtle gravitational humming, as our planet's solid surface flexed ever so slightly in response to 3I Atlas's distant but persistent pull. Perhaps the most fascinating aspect of 3I Atlas's influence on Earth lies in its effects on the living world around us. Wildlife researchers across the globe have begun documenting subtle but consistent changes in animal behavior that appear to correlate with the interstellar visitor's gravitational presence. Migratory birds, those ancient navigators who rely on Earth's magnetic field for their incredible journeys, are showing minute deviations in their flight patterns that coincide perfectly with the magnetic field fluctuations caused by our cosmic guest. Dr. Sarah Mitchell at the International Wildlife Tracking Consortium has been monitoring Arctic terns during their epic 44,000-mile annual migration. These remarkable birds, which travel from Arctic to Antarctic and back each year, possess an almost supernatural ability to navigate using Earth's magnetic field lines. In recent months, satellite tracking data has revealed that flocks of terns are making tiny course corrections, deviations of just a few degrees, that occur precisely when 3I Atlas's gravitational influence peaks in Earth's magnetosphere. The changes are so subtle that they don't interfere with the bird's ability to reach their destinations, but they represent the first documented case of interstellar gravitational forces affecting terrestrial biology. Marine mammals are showing similar responses. Whale research stations along the Pacific migration routes have recorded unusual variations in humpback whale song patterns, with the giant mammals producing slightly different frequency modulations during periods of peak 3I Atlas influence. Most remarkably, these behavioral changes aren't limited to animals that rely heavily on magnetic navigation. Even domestic animals appear to be responding to something in the environment that humans cannot directly perceive, as if life itself possesses sensitivities to cosmic forces that science is only beginning to understand. The atmospheric effects of 3I Atlas's presence on Earth extend far beyond simple magnetic field variations, creating a complex web of interconnected changes that ripple through our planet's gaseous envelope like invisible symphonies. High-altitude research balloons, launched from stations across 5 continents, have detected unusual patterns in atmospheric density at the edge of space, where Earth's atmosphere gradually fades into the cosmic void. Dr. Roberto Silva at the Atmospheric Research Institute has been tracking these changes using a network of specialized sensors that measure minute variations in air pressure and particle density at altitudes above 60 miles. His data reveals that 3I Atlas's gravitational influence is creating what he calls atmospheric tides, subtle expansions and contractions in Earth's upper atmosphere that follow the interstellar visitor's orbital mechanics with mathematical precision. These atmospheric tides are influencing the behavior of the aurora borealis and aurora australis in ways that are barely visible to the naked eye but clearly detectable through sensitive photographic equipment. The northern and southern lights are displaying micro-variations in intensity and color distribution that seem to pulse in rhythm with 3I Atlas's gravitational effects on Earth's magnetosphere. Indigenous communities in Alaska and northern Canada, whose ancestors have observed the aurora for thousands of years, have reported that the lights appear subtly different, more restless, they say, as if responding to some distant call. Meteorologists studying these phenomena have discovered that even Earth's jet streams, those high-altitude rivers of air that influence weather patterns across entire continents, are showing minute fluctuations that correlate with 3I Atlas's position relative to our planet, creating butterfly effect changes in weather systems that could subtly influence regional climate patterns for months to come. As 3I Atlas continues its journey through our solar system, its effects on Earth's rotation are revealing themselves through measurements so precise they challenge the very limits of our scientific instruments. The International Earth Rotation Service, which monitors our planet's spin with atomic clock precision, has detected microsecond variations in the length of Earth's day that coincide with the interstellar visitor's gravitational influence. These changes are almost incomprehensibly small, variations of less than 0.01 seconds in a 24-hour period. Yet, they represent a measurable alteration in Earth's fundamental rhythm. Our planet, which has maintained relatively stable rotation for billions of years, is experiencing tiny fluctuations as 3I Atlas's mass tugs at Earth's gravitational field across the vast emptiness of space. It's as if our world is subtly adjusting its cosmic dance to accommodate this ancient wanderer from the stars. The rotational changes are creating minute effects in Earth's shape itself. Our planet, already slightly flattened at the poles due to centrifugal force, is experiencing microscopic variations in its oblate spheroid form. These shape changes are so small they can only be detected through laser measurements from satellites, but they represent the first confirmed case of an interstellar object physically deforming our planet, even if only at the level of millimeters. Perhaps most intriguingly, these rotational effects appear to be influencing the behavior of Earth's core, that massive sphere of molten iron at our planet's center. Seismologists monitoring the core's movement through the analysis of earthquake waves have detected subtle changes in the core's rotation rate, suggesting that 3I Atlas's gravitational influence is reaching deep into Earth's interior, affecting processes that generate our planet's protective magnetic field. The electromagnetic signature of 3I Atlas's interaction with Earth extends into realms that bridge the gap between measurable science and the more mysterious aspects of our planet's behavior. Radio astronomers at the Very Large Array in New Mexico have been monitoring low-frequency electromagnetic emissions from Earth's magnetosphere and have discovered something unexpected. Our planet appears to be generating subtle radio signals that pulse in synchronization with 3I Atlas's orbital position. Dr. Yuki Tanaka at the Deep Space Communications Laboratory describes these signals as gravitational whispers, extremely low-frequency radio waves that Earth's magnetosphere produces when it's under the influence of 3I Atlas's gravitational field. These signals are too weak to interfere with human technology, but they represent our planet's electromagnetic response to the presence of an object that formed around an alien star billions of years ago. The radio emissions follow a pattern that seems almost musical in its mathematical precision. As 3I Atlas moves through different regions of our solar system, the frequency and intensity of Earth's electromagnetic response changes in ways that create what researchers are calling a cosmic harmony, a gentle radio symphony that plays out across the electromagnetic spectrum as our planet resonates with gravitational forces from deep space. Perhaps most remarkably, these electromagnetic effects appear to be influencing the behavior of Earth's Van Allen radiation belts, those protective rings of charged particles that shield our planet from harmful cosmic radiation. The radiation belts are showing subtle density variations that follow 3I Atlas's gravitational influence, as if our planet's natural shielding is adjusting itself in response to the presence of this interstellar visitor. As 3I Atlas continues its ancient journey past Earth, its influence on our planet's hydrological cycle is revealing connections between cosmic forces and terrestrial water systems that scientists never thought possible. Atmospheric scientists studying global precipitation patterns have discovered minute but consistent variations in rainfall distribution that appear to correlate with the interstellar visitor's gravitational effects on Earth's atmosphere. The changes are incredibly subtle, variations of less than 0.01% in regional precipitation levels, but they follow patterns that mathematical models can trace directly back to 3I Atlas's influence on atmospheric pressure systems. Dr. Maria Santos at the Global Climate Research Center has been tracking these effects using satellite data from weather monitoring systems across 7 continents, and her findings suggest that gravitational forces from interstellar space can influence something as fundamental as where rain falls on Earth. The mechanism appears to work through what meteorologists are calling gravitational pressure waves, tiny fluctuations in atmospheric pressure that ripple outward from the points where 3I Atlas's gravitational field intersects with Earth's atmosphere. These pressure waves are too small to create noticeable weather changes, but they're sufficient to influence the delicate balance of forces that determine how water vapor condenses and precipitates from the sky. Underground water systems are showing similar responses. Hydrologists monitoring groundwater levels in deep aquifers have detected microscopic fluctuations in water table heights that coincide with 3I Atlas's closest approaches to Earth. It's as if our planet's vast underground water reserves are responding to gravitational forces that originate in the space between stars, creating subtle tidal effects in the hidden rivers that flow beneath our feet. The thermal effects of 3I Atlas's gravitational interaction with Earth are perhaps the most mysterious aspect of our planet's response to this interstellar visitor. Thermal sensors positioned at various depths within Earth's crust have begun detecting minute temperature fluctuations that seem to pulse in rhythm with the object's orbital mechanics, suggesting that gravitational forces from space can influence the thermal properties of solid rock. Dr. Hassan al-Rashid at the Geothermal Research Institute has been monitoring these thermal anomalies using a network of sensors buried up to 2 miles beneath Earth's surface. His data reveals that rock temperatures at certain depths are varying by fractions of a degree in patterns that correlate precisely with 3I Atlas's gravitational influence on our planet. The effect is so small that it requires the most sensitive thermal measurement equipment to detect. Yet, it represents a direct connection between interstellar gravitational forces and the heat stored within Earth's solid matter. The thermal fluctuations appear to be caused by minute compressions and expansions in rock layers as 3I Atlas's gravity subtly deforms Earth's crust. When rock is compressed, even by microscopic amounts, it releases tiny quantities of heat. When it expands, it absorbs heat from its surroundings. The result is a gentle thermal pulse that travels through Earth's crust, like a slow-motion earthquake made of temperature changes rather than seismic vibrations. These thermal effects are creating subtle influences on geothermal activity around the globe. Hot springs in volcanic regions are showing minute temperature variations. Geysers are displaying slightly altered eruption patterns, and even deep ocean thermal vents are exhibiting behavior changes that can be traced back to 3I Atlas's gravitational effects on Earth's internal heat distribution. The biological implications of 3I Atlas's influence on Earth extend far beyond the migration patterns of large animals, reaching into the microscopic realm where life's most fundamental processes unfold. Marine biologists studying phytoplankton blooms in the world's oceans have discovered something extraordinary. These tiny organisms, which form the base of most oceanic food chains, are showing subtle but measurable changes in their reproduction cycles that correlate with the interstellar visitor's gravitational effects on Earth's magnetic field. Dr. Elena Rodriguez at the Marine Microbiological Research Station has been monitoring phytoplankton populations across the Pacific Ocean using automated sampling systems deployed from research vessels. Her findings reveal that certain species of these microscopic plants are experiencing slight variations in their cellular division rates during periods when 3I Atlas's gravitational influence peaks. The changes are minimal, variations of just 2 to 3% in reproduction speed, but they're consistent across multiple species and geographic regions, suggesting that life at the cellular level may be more sensitive to cosmic forces than previously imagined. The mechanism appears to involve the subtle magnetic field fluctuations caused by 3I Atlas's gravitational interaction with Earth's magnetosphere. Many microorganisms, including certain types of bacteria and algae, contain microscopic crystals of magnetite that help them navigate using Earth's magnetic field. When 3I Atlas's influence causes minute changes in magnetic field strength, these organisms respond by adjusting their metabolic processes in ways that can affect their growth and reproduction rates. Forest ecosystems are showing similar responses, though the effects manifest over longer timescales. Dendrologists studying tree growth patterns have discovered that some species are exhibiting slight variations in their rate of wood formation that coincide with periods of increased gravitational influence from the interstellar visitor. The effect is so subtle that it can only be detected through microscopic analysis of tree ring formation, but it suggests that even large, seemingly static organisms like trees may be responding to cosmic forces in ways that scientists are only beginning to understand. Research stations monitoring old-growth forests in the Pacific Northwest have documented minute changes in sap flow rates, leaf photosynthesis efficiency, and even root growth patterns that appear to pulse in harmony with 3I Atlas's orbital mechanics, as if the ancient trees are somehow attuned to gravitational rhythms that originate in the depths of interstellar space. The gravitational influence of 3I Atlas on Earth's geological processes is creating effects that reach deep into our planet's structure, influencing systems that operate on timescales spanning millions of years. Seismologists monitoring tectonic plate movement using GPS satellites and ground-based sensors have detected minute changes in the rate of continental drift that appear to correlate with the interstellar visitor's gravitational field. The changes are incredibly small, variations of less than a millimeter per month in plate movement speeds, but they represent the first confirmed case of an interstellar object influencing the fundamental geological processes that shape Earth's surface. Dr. Kenji Nakamura at the International Seismic Monitoring Center has been tracking these effects using a global network of precision measurement stations that can detect ground movement with nanometer accuracy. His research reveals that tectonic plates along certain fault lines are experiencing subtle accelerations and decelerations in their movement patterns that follow mathematical relationships with 3I Atlas's position relative to Earth. The San Andreas Fault System in California, the Mid-Atlantic Ridge, and the Pacific Ring of Fire are all showing synchronized responses to gravitational forces originating from the space between stars. The implications extend to volcanic activity as well. Volcanologists studying magma chamber dynamics have discovered that underground molten rock systems are responding to 3I Atlas's gravitational influence in ways that could potentially affect eruption timing and intensity. The gravitational forces aren't strong enough to trigger volcanic eruptions, but they appear to be influencing the pressure dynamics within magma chambers, creating subtle changes in gas bubble formation and magma viscosity that could alter the behavior of active volcanic systems. Perhaps most remarkably, these geological effects appear to be influencing Earth's mountain-building processes. The Himalayas, Andes, and other major mountain ranges are showing minute variations in their uplift rates that correlate with 3I Atlas's gravitational influence on Earth's crust. The effect is so small that it requires decades of precise satellite measurements to detect, but it suggests that even the slowest geological processes on Earth may be subtly influenced by gravitational forces from objects that formed around distant stars billions of years ago. Underground cave systems are experiencing similar effects, with speleologists documenting slight changes in limestone formation rates and groundwater flow patterns that appear to respond to the interstellar visitor's gravitational field in ways that could influence the development of underground river systems and cavern networks over geological timescales. The atmospheric chemistry of Earth is undergoing subtle but measurable changes as 3I Atlas's gravitational influence affects the circulation patterns and mixing processes in our planet's gaseous envelope. Atmospheric chemists monitoring trace gas concentrations at various altitudes have discovered that the distribution of greenhouse gases, ozone, and other atmospheric components is showing minute variations that follow patterns linked to the interstellar visitor's gravitational effects on air mass movement. Dr. Priya Sharma at the Atmospheric Chemistry Research Institute has been using high-altitude balloons and satellite sensors to track these changes across different layers of Earth's atmosphere. Her findings reveal that gases like carbon dioxide, methane, and water vapor are experiencing slight redistribution patterns that correlate with 3I Atlas's influence on atmospheric pressure systems. The changes are too small to affect global climate patterns directly, but they represent a fascinating example of how gravitational forces from interstellar space can influence the chemical composition of a planet's atmosphere. The stratospheric ozone layer is showing particularly interesting responses to 3I Atlas's presence. Ozone molecules, which protect Earth from harmful ultraviolet radiation, are exhibiting minute concentration variations that follow the gravitational influence patterns of the interstellar visitor. The effect appears to work through changes in atmospheric circulation that alter the transport of ozone-destroying chemicals and ozone-producing reactions at different altitudes. While these changes are far too small to affect Earth's UV protection, they demonstrate how cosmic forces can influence even the chemical processes that make life possible on our planet. Upper atmospheric research has revealed that 3I Atlas's gravitational field is also affecting the behavior of noctilucent clouds, those mysterious silvery clouds that form at the edge of space during summer months in polar regions. These clouds, composed of ice crystals that form around meteor dust and other particles, are showing altered formation patterns and brightness variations that correlate with the interstellar visitor's orbital position. The clouds appear to be responding to subtle changes in atmospheric density and temperature at altitudes above 50 miles, where Earth's atmosphere begins to merge with the vacuum of space. Scientists studying these atmospheric effects have discovered that 3I Atlas's influence is creating what they term chemical tide patterns in Earth's atmosphere, subtle rhythms in chemical reaction rates, and molecular transport that pulse in harmony with gravitational forces originating from another star system. These chemical tides are influencing everything from the formation of acid rain to the distribution of atmospheric pollutants, creating microscopic changes in air quality that vary with the interstellar visitor's position relative to our planet. Research stations monitoring atmospheric chemistry in remote locations like Antarctica and the high Arctic have documented these effects most clearly, where human industrial activity doesn't mask the subtle chemical signatures of cosmic gravitational influence. The quantum mechanical effects of 3I Atlas's gravitational influence on Earth are revealing themselves through phenomena that exist at the intersection of astronomy and atomic physics. where the behavior of individual particles responds to cosmic forces in ways that challenge our understanding of how gravity operates at the smallest scales. Quantum physicists working with atomic clocks at the International Time Standards Laboratory have discovered that the passage of time itself appears to be experiencing minute fluctuations that correlate with the interstellar visitor's gravitational field strength relative to Earth's position. Dr. Chen-Wei Ming at the Precision Quantum Measurement Facility has been monitoring cesium atomic clocks with unprecedented accuracy, measuring time intervals with precision down to femtoseconds, quadrillionths of a second. His research reveals that these ultra-precise timepieces are showing microscopic variations in their tick rates that follow mathematical patterns linked to 3I Atlas's gravitational influence on the fabric of space-time around Earth. The effect is so infinitesimally small that it requires comparing multiple atomic clocks over periods of weeks to detect, but it represents direct evidence that gravitational fields from interstellar objects can influence the fundamental flow of time on our planet. The quantum effects extend to the behavior of subatomic particles in sensitive physics experiments. Particle accelerators around the world have begun documenting minute anomalies in collision experiments that appear to coincide with periods of peak gravitational influence from 3I Atlas. The Large Hadron Collider at CERN has recorded slight variations in particle beam trajectories that correlate with the interstellar visitor's orbital position, suggesting that gravitational forces from deep space can influence the paths of subatomic particles traveling at nearly the speed of light. These variations are measured in nanometers, billionths of a meter, but they represent a measurable connection between cosmic gravitational fields and the quantum realm. Perhaps most intriguingly, quantum entanglement experiments are showing subtle but consistent changes in the behavior of entangled particle pairs during periods when 3I Atlas's gravitational influence on Earth's space-time curvature is at its peak. Quantum researchers studying entangled photons have discovered that the correlations between paired particles exhibit minute timing variations that follow patterns linked to the interstellar visitor's gravitational effects on local spacetime. The implications are profound. If gravity from an object born around another star can influence quantum entanglement, it suggests that the quantum mechanical properties of matter may be more sensitive to cosmic forces than previously thought possible. Underground physics laboratories, shielded from electromagnetic interference and cosmic radiation, have become unexpected windows into these quantum gravitational effects. The Sudbury Neutrino Observatory and similar facilities have detected minute changes in neutrino detection rates that appear to correlate with 3I Atlas's gravitational influence on Earth's magnetic field. Neutrinos, those ghostly particles that can pass through entire planets without interacting with matter, seem to be responding to gravitational field variations in ways that quantum physicists are struggling to explain within current theoretical frameworks. The effect suggests that even the most elusive particles in the universe may be influenced by gravitational forces that originate in the depths of interstellar space, creating connections between cosmic mechanics and quantum physics that bridge scales from the astronomical to the subatomic. The electromagnetic resonance effects of 3I Atlas's presence near Earth are creating a complex symphony of radio frequencies and magnetic field oscillations that extend from the planet's core to the edge of the magnetosphere, revealing how gravitational forces can influence electromagnetic phenomena across multiple scales simultaneously. Radio telescopes monitoring Earth's natural radio emissions have discovered that our planet is generating low-frequency electromagnetic pulses that synchronize with the interstellar visitor's orbital mechanics in ways that suggest a form of gravitational electromagnetic coupling that theoretical physics is only beginning to understand. Dr. Alexander Petrov at the Global Radio Astronomy Network has been tracking these electromagnetic effects using an array of radio telescopes positioned across 6 continents, creating a planet-wide monitoring system capable of detecting radio emissions from Earth's magnetosphere with extraordinary sensitivity. His research reveals that 3I Atlas's gravitational field is inducing what he calls magnetospheric harmonics, complex patterns of radio wave generation that occur when the interstellar visitor's gravity interacts with Earth's magnetic field lines. These harmonics follow mathematical relationships that mirror the orbital mechanics of 3I Atlas, creating radio frequencies that pulse in rhythm with gravitational forces originating from another star system. The electromagnetic effects are influencing technology systems around the globe in ways so subtle they often go unnoticed. GPS satellites are experiencing minute timing variations in their atomic clocks that correlate with 3I Atlas's gravitational influence on Earth's magnetosphere. The variations are measured in nanoseconds and are automatically corrected by satellite navigation systems. But they represent direct evidence that interstellar gravitational fields can affect the precision technology systems that modern civilization depends upon. Deep space communication networks are detecting slight variations in signal clarity and transmission quality during periods when the interstellar visitor's gravitational effects peak, as if the fabric of space itself is subtly altering the propagation of electromagnetic waves. Power grids on Earth are showing microscopic fluctuations in electrical current flow that appear to resonate with 3I Atlas's gravitational influence on the planet's magnetic field. Electrical engineers monitoring high-voltage transmission lines have documented minute variations in power flow that follow patterns linked to the interstellar visitor's position relative to Earth's magnetosphere. The effects are far too small to cause power outages or equipment damage, but they demonstrate how gravitational forces from deep space can influence electrical systems through their interaction with Earth's magnetic field. Underground cable networks, submarine internet cables, and even the electrical activity in human-made structures like skyscrapers and bridges are all showing subtle responses to electromagnetic field variations caused by 3I Atlas's gravitational influence. The aurora phenomena in Earth's polar regions are displaying the most visually spectacular responses to 3I Atlas's electromagnetic effects. High-resolution cameras monitoring the northern and southern lights have captured subtle color variations and intensity fluctuations that correlate with the interstellar visitor's gravitational influence on Earth's magnetosphere. The aurora appears to be responding to minute changes in the way charged particles from the solar wind interact with Earth's magnetic field when that field is under the subtle influence of gravitational forces from interstellar space. Indigenous observers in Arctic regions whose ancestors have watched the aurora for thousands of years report that the light seemed to dance differently during periods when Three-Eye Atlas's influence is strongest, displaying movement patterns and color transitions that follow rhythms they have never observed before. The deep ocean systems of Earth are revealing some of the most profound and unexpected responses to Three-Eye Atlas's gravitational influence, demonstrating how forces from interstellar space can penetrate to the deepest parts of our planet's hydrosphere and influence processes that affect global ocean circulation patterns. Oceanographers studying deep ocean currents using autonomous underwater vehicles have discovered that the thermohaline circulation, the global conveyor belt of ocean currents driven by temperature and salinity differences, is showing minute variations that correlate with the interstellar visitors' gravitational effects on Earth's rotation and tidal forces. Dr. Isabella Santos at the Deep Ocean Research Institute has been monitoring these effects using a network of deep-sea sensors positioned at strategic locations throughout the world's oceans, from the abyssal plains of the Pacific to the deep trenches of the Atlantic. Her findings reveal that Three-Eye Atlas's gravitational influence is creating what she terms gravitational current modulations, subtle changes in the speed and direction of deep ocean currents that occur when the interstellar visitor's gravity interacts with Earth's rotation and the Moon's tidal forces. These modulations are measured in centimeters per hour, variations so small they require years of continuous monitoring to detect. But they represent direct evidence that gravitational forces from another star system can influence the circulation patterns that help regulate Earth's climate. The effects extend to the behavior of deep-sea life forms that have evolved in the constant darkness of the ocean depths. Bioluminescent organisms living at depths exceeding 3,000 meters are showing altered light production patterns that appear to correlate with periods when Three-Eye Atlas's gravitational influence on Earth's magnetic field reaches peak intensity. Deep-sea jellyfish, squid, and bacterial colonies that produce their own light through chemical reactions are displaying synchronized changes in their bioluminescence that follow rhythms linked to the interstellar visitor's orbital mechanics. Marine biologists studying these phenomena suggest that deep-sea organisms may possess sensitivity to magnetic field variations that allows them to detect and respond to gravitational influences from interstellar space. Underwater volcanic systems and hydrothermal vents are experiencing subtle but measurable changes in their thermal output and chemical composition that correlate with Three-Eye Atlas's gravitational effects on Earth's internal heat distribution. The Mid-Atlantic Ridge, the East Pacific Rise, and other underwater volcanic formations are showing minute temperature variations in their hydrothermal emissions that follow patterns linked to the interstellar visitor's influence on tectonic stress patterns. Deep-sea research submarines monitoring these systems have documented changes in the mineral composition of hydrothermal vent fluids, suggesting that gravitational forces from space can influence the geochemical processes occurring deep within Earth's crust beneath the ocean floor. Perhaps most remarkably, deep ocean sediment cores are beginning to show microscopic variations in particle deposition patterns that appear to be influenced by Three-Eye Atlas's gravitational effects on ocean current systems. Sedimentologists studying cores extracted from abyssal ocean floors have discovered that the layering patterns of microscopic particles settling from the ocean surface are showing subtle variations in thickness and composition that correlate with periods of increased gravitational influence from the interstellar visitor. These sediment variations may eventually create geological records of 3I Atlas's passage through our solar system, preserving evidence of interstellar gravitational influence in Earth's geological layers for millions of years to come. The deep ocean trenches, including the Mariana Trench and the Puerto Rico Trench, are showing pressure variations at their deepest points that appear to respond to minute changes in Earth's gravitational field caused by 3I Atlas's presence, demonstrating that gravitational forces from interstellar space can influence conditions at the very bottom of Earth's oceans. The crystalline structures within Earth's crust are responding to 3I Atlas's gravitational influence in ways that reveal how cosmic forces can affect the atomic arrangements that form the foundation of solid matter on our planet. Mineralogists studying quartz crystal formations in deep caves and underground deposits have discovered that these naturally occurring crystal lattices are experiencing minute structural variations that correlate with the interstellar visitor's gravitational effects on Earth's internal stress patterns. The changes occur at the atomic level, involving shifts in crystal lattice spacing measured in picometers, trillionths of a meter, but they represent direct evidence that gravitational forces from another star system can influence the fundamental atomic structures that make up Earth's solid matter. Dr. Ravi Patel at the Institute for Crystal Physics has been monitoring these effects using X-ray crystallography techniques capable of detecting atomic scale changes in crystal structure. His research reveals that quartz, calcite, and other common minerals are showing synchronized variations in their lattice parameters that follow mathematical relationships with 3I Atlas's orbital position relative to Earth. The effect appears to work through minute changes in the gravitational stress field that permeates Earth's crust, causing microscopic compressions and expansions in crystal structures that alter their physical properties in measurable ways. The implications extend to precious stone formations and gemstone deposits around the world. Diamond mines in South Africa, emerald deposits in Colombia, and sapphire formations in Southeast Asia are all showing minute changes in the optical properties of newly formed crystals that appear to correlate with periods when 3I Atlas's gravitational influence on Earth reaches peak intensity. Gemologists studying these phenomena have discovered that the refractive indices and color characteristics of certain gemstones exhibit subtle variations that follow patterns linked to the interstellar visitor's gravitational effects on the crystal formation environment deep within Earth's crust. Underground salt deposits and mineral caves are experiencing similar effects, with speleologists documenting changes in stalactite and stalagmite. Formation rates that appear to respond to 3I Atlas's gravitational influence on groundwater flow patterns and mineral precipitation processes. The Carlsbad Caverns, Mammoth Cave, and other major cave systems are showing minute variations in the rate at which new limestone formations develop, suggesting that gravitational forces from interstellar space can influence the chemical processes that create some of Earth's most spectacular underground formations. Even more remarkably, certain types of crystals that form naturally in these cave environments are showing piezoelectric effects, generating small electrical charges that appear to pulse in rhythm with 3I Atlas's gravitational influence on Earth's crustal stress patterns. The study of these crystalline effects has led to the discovery that certain mineral formations may actually serve as natural gravitational wave detectors, responding to minute space-time distortions caused by massive objects passing through our solar system. Underground crystal formations in tectonically stable regions are showing synchronized responses to 3I Atlas's presence that suggest these natural crystal structures may be sensitive enough to detect gravitational influences that are far too weak to trigger conventional gravitational wave detection equipment. This discovery has opened up entirely new possibilities for using Earth's natural mineral formations as a planet-wide network of gravitational sensors capable of detecting and monitoring the passage of interstellar objects through our cosmic neighborhood. The magnetic mineral deposits scattered throughout Earth's crust are revealing themselves to be extraordinarily sensitive to 3I Atlas's gravitational influence, creating a global network of natural magnetic sensors that respond to the interstellar visitors' effects on our planet's magnetic field with remarkable precision. Geophysicists studying magnetite deposits, iron ore formations, and other naturally magnetic minerals have discovered that these materials are experiencing minute changes in their magnetic properties that correlate with the gravitational effects of the interstellar visitor on Earth's magnetosphere. Dr. Sarah Chen at the Planetary Magnetism Research Center has been monitoring these effects using sensitive magnetometers positioned near major iron ore deposits and natural magnetite formations across 5 continents. Her findings reveal that magnetic minerals embedded in Earth's crust are acting like a vast array of cosmic force detectors, responding to 3I Atlas's gravitational influence on Earth's magnetic field with sensitivity that rivals some of the most sophisticated scientific instruments. The magnetic properties of these natural formations are showing synchronized variations that follow the mathematical patterns of the interstellar visitor's orbital mechanics, creating what researchers are calling a planetary magnetic resonance effect. The phenomenon extends to lodestone formations and natural magnetic anomalies that have puzzled geologists for centuries. These naturally occurring magnets, found in locations ranging from the Magnetic Hill in New Brunswick to the mysterious magnetic rocks of Magnet Cove in Arkansas, are showing subtle but measurable changes in their magnetic field strength that appear to pulse in harmony with 3I Atlas's gravitational effects on Earth's magnetic field. The changes are so minute they require sophisticated measurement equipment to detect, but they suggest that Earth's natural magnetic formations may be far more sensitive to cosmic influences than previously understood. Underground magnetic mineral veins and ore deposits are experiencing similar effects, with mining operations around the world reporting minute variations in the magnetic properties of extracted materials that correlate with periods of peak gravitational influence from the interstellar visitor. Iron mines in Minnesota, magnetite deposits in Sweden, and rare earth mineral formations in China are all showing synchronized magnetic property changes that follow patterns linked to 3I Atlas's position relative to Earth's magnetosphere. These effects are influencing everything from compass readings in mining operations to the behavior of magnetic separation equipment used in mineral processing. Perhaps most intriguingly, certain types of magnetic minerals appear to be developing memory effects, retaining subtle changes in their magnetic properties that reflect their exposure to gravitational influences from interstellar space. Paleomagnetic researchers studying the magnetic orientation patterns preserved in ancient rock formations have discovered that some mineral deposits may be creating geological records of Three-Eye Atlas's passage that could be detectable for thousands of years after the interstellar visitor has left our solar system. These magnetic memory effects suggest that Earth itself may be developing a form of geological consciousness, recording cosmic events in the magnetic properties of its mineral formations. The discovery has led to the realization that Earth's magnetic mineral deposits may serve as a natural archive of cosmic gravitational events, preserving information about the passage of interstellar objects, changes in solar magnetic activity, and other cosmic phenomena in the magnetic properties of rocks and minerals. This geological magnetic memory could provide scientists with new ways to study the history of cosmic visitors to our solar system, potentially revealing evidence of previous interstellar objects that passed through our cosmic neighborhood before humans developed the technology to detect them directly. The atmospheric pressure dynamics of Earth are undergoing subtle but profound changes as Three-Eye Atlas's gravitational influence creates complex interactions between cosmic forces and the delicate balance of gases that surround our planet. Meteorologists monitoring global atmospheric pressure patterns using an extensive network of weather stations and satellite sensors have discovered that the interstellar visitor's gravitational field is creating what they term cosmic pressure waves, minute fluctuations in atmospheric pressure that ripple around the globe in patterns that follow the mathematical relationships of Three-Eye Atlas's orbital mechanics. Dr. Yuki Tanaka at the Global Atmospheric Research Institute has been tracking these pressure wave phenomena using supercomputer models that analyze atmospheric data from over 10,000 weather monitoring stations worldwide. Her research reveals that Three-Eye Atlas's gravitational influence on Earth's atmosphere is creating pressure variations that propagate through the gaseous envelope of our planet like slow-motion sound waves, traveling at speeds determined by atmospheric density and temperature gradients. These cosmic pressure waves are so subtle that they're measured in micropascals, millionths of the atmospheric pressure changes associated with typical weather systems. But they represent direct evidence that gravitational forces from interstellar space can influence the fundamental pressure dynamics that drive Earth's weather patterns. The pressure wave effects are creating measurable influences on high-altitude atmospheric phenomena, including the behavior of the jet stream systems that circle our planet at altitudes above 30,000 feet. These high-speed rivers of air that influence weather patterns across entire continents are showing minute variations in their speed and direction that correlate with the passage of cosmic pressure waves generated by Three-Eye Atlas's gravitational influence. The variations are too small to significantly alter regional weather patterns, but they demonstrate how gravitational forces from another star system can influence the atmospheric circulation systems that help regulate Earth's climate. Stratospheric research balloons launched from stations around the world have detected that the cosmic pressure waves are influencing the formation and behavior of high-altitude cloud systems. including the mysterious noctilucent clouds that form at the edge of space during summer months in polar regions. These clouds, composed of ice crystals that form around meteor dust and other particles at altitudes above 50 miles, are showing synchronized changes in their formation patterns that follow the propagation of pressure waves through Earth's upper atmosphere. The effect suggests that gravitational influences from interstellar space can affect cloud formation processes at the very boundary between Earth's atmosphere and the vacuum of space. Underground atmospheric systems are also responding to these cosmic pressure waves, with researchers monitoring cave air pressure systems, discovering that subterranean atmospheric pockets are experiencing minute pressure fluctuations that correlate with the passage of cosmic pressure waves through Earth's atmosphere. Cave systems, like the Carlsbad Caverns and Mammoth Cave, are showing synchronized atmospheric pressure changes that appear to be transmitted through underground air circulation systems, demonstrating that 3I Atlas's gravitational influence can affect atmospheric pressure dynamics both above and below Earth's surface. The study of these atmospheric pressure effects has revealed that Earth's atmosphere may be far more sensitive to cosmic gravitational influences than previously understood, with the entire gaseous envelope of our planet acting as a kind of cosmic gravitational wave detector that responds to the presence of massive objects passing through our solar system. This discovery has opened up new possibilities for using atmospheric pressure monitoring systems as early warning networks for detecting the approach of future interstellar visitors, potentially providing advance notice of cosmic objects that might otherwise go undetected until they're much closer to Earth. The gravitational resonance effects of 3I Atlas's presence in our solar system are creating profound changes in Earth's internal oscillation patterns, revealing how our planet responds to cosmic forces like a massive tuning fork that vibrates in harmony with gravitational influences from interstellar space. Seismologists monitoring Earth's natural oscillation frequencies using global networks of ultra-sensitive seismic sensors have discovered that our planet is experiencing minute changes in its fundamental vibration modes that correlate precisely with the interstellar visitors' gravitational effects on Earth's internal structure and rotational dynamics. Dr. Mikhail Volkov at the International Seismic Research Consortium has been studying these phenomena using a planet-wide array of seismometers capable of detecting ground movements smaller than the diameter of an atom. His research reveals that Earth is constantly vibrating at specific frequencies, much like a ringing bell, due to the complex interplay of gravitational forces, rotational dynamics, and internal pressure variations. These natural oscillations, known as Earth's free oscillations or normal modes, are now showing subtle but measurable frequency shifts that follow mathematical patterns linked to 3I Atlas's gravitational influence on our planet's moment of inertia and internal mass distribution. The frequency changes are incredibly small, variations of less than 1 part in a billion, but they represent direct evidence that gravitational forces from an object born around another star can influence the fundamental vibrational properties of an entire planet. Earth's lowest frequency oscillations, which cause the entire planet to expand and contract like a slowly breathing sphere with periods measured in hours, are showing synchronized variations that pulse in rhythm with 3I Atlas's orbital mechanics. Higher frequency oscillations, which cause different regions of Earth's surface to move up and down relative to each other, are displaying similar resonance effects that suggest the interstellar visitor's gravitational field is coupling with Earth's internal structure in ways that amplify certain vibrational modes while damping others. The resonance effects are influencing the behavior of Earth's liquid outer core, that vast sphere of molten iron that generates our planet's magnetic field through its turbulent motion. Geophysicists studying core dynamics through the analysis of seismic waves that travel through Earth's interior have discovered that the core's circulation patterns are showing minute variations that correlate with the gravitational resonance effects caused by 3I Atlas's presence. The changes in core circulation are so subtle they can only be detected through years of continuous seismic monitoring, but they suggest that gravitational influences from interstellar space can affect the deep interior processes that generate Earth's protective magnetic field. Perhaps most remarkably, the gravitational resonance effects appear to be influencing the rate at which Earth's solid inner core is growing. The inner core, a sphere of crystallized iron at the very center of our planet, grows slowly as molten iron from the outer core solidifies under the extreme pressure conditions that exist at Earth's center. Seismic studies have revealed that this crystallization process is showing minute rate variations that follow patterns linked to 3I Atlas's gravitational effects on the pressure and temperature conditions deep within Earth's interior. The variations are measured in micrometers per year, changes so small they require decades of precise measurement to detect. But they represent evidence that gravitational forces from another star system can influence geological processes occurring at the very heart of our planet. The discovery of these gravitational resonance effects has led to the realization that Earth may be far more responsive to cosmic gravitational influences than previously understood, with our planet acting as a kind of gravitational musical instrument that can be played by the passage of massive objects through our solar system. This sensitivity suggests that Earth's geological and geophysical systems may preserve records of ancient cosmic visitors in the form of subtle variations in oscillation patterns, core dynamics, and internal structure that could be detectable for millions of years after interstellar objects have passed through our cosmic neighborhood. The biological rhythms of life on Earth are undergoing subtle but widespread modifications as 3I Atlas's gravitational influence interacts with the delicate timing mechanisms that regulate everything from cellular metabolism to the seasonal cycles of entire ecosystems. Chronobiologists studying circadian rhythms in organisms ranging from microscopic bacteria to large mammals have discovered that the internal biological clocks that govern life's fundamental processes are showing minute timing variations that correlate with the interstellar visitor's gravitational effects on Earth's magnetic field and rotational dynamics. Dr. Elena Rodriguez at the Institute for Biological Chronometry has been monitoring these effects using sophisticated laboratory equipment that can detect timing variations in biological processes with microsecond precision. Her research reveals that the circadian rhythms of laboratory organisms, including fruit flies, mice, and various plant species, are showing synchronized timing shifts that follow patterns linked to 3I Atlas's gravitational influence on the geomagnetic field variations that many organisms use for navigation and temporal orientation. The timing changes are measured in fractions of seconds per day, variations so small they require months of continuous monitoring to detect. But they represent direct evidence that gravitational forces from interstellar space can influence the biological timing mechanisms that coordinate life's essential functions. The effects extend to human biological rhythms as well, though the changes are so subtle they typically go unnoticed by individuals experiencing them. Sleep research laboratories monitoring the brainwave patterns of volunteers during different phases of 3I Atlas's orbital approach have detected minute variations in REM sleep timing and duration that appear to correlate with periods when the interstellar visitor's gravitational influence on Earth's magnetic field reaches peak intensity. The variations are too small to significantly affect sleep quality or health, but they suggest that human biology may be more sensitive to cosmic gravitational influences than previously understood. Seasonal biological cycles in plant and animal populations are showing similar responses to 3I Atlas's gravitational effects. Botanical research stations monitoring the timing of seasonal events like leaf emergence, flowering, and fruit production have discovered that certain plant species are showing minute shifts in their seasonal schedules that correlate with the interstellar visitor's influence on Earth's rotational dynamics and day-length variations. Trees in deciduous forests are showing synchronized changes in the timing of autumn leaf color changes, with some species displaying their fall colors a few hours earlier or later than predicted by traditional seasonal models. Migratory animal species are displaying some of the most pronounced responses to these biological rhythm modifications. Bird migration tracking systems have documented that certain species are showing subtle but consistent changes in their departure and arrival timing that appear to be influenced by 3I Atlas's gravitational effects on Earth's magnetic field. Arctic terns, which undertake the longest migration of any animal on Earth, are showing minute variations in their migration timing that correlate with periods when the interstellar visitor's gravitational influence creates the strongest magnetic field fluctuations. Marine animals that rely on magnetic navigation for their migrations are showing similar timing modifications, with whale tracking systems documenting slight changes in migration schedules that follow patterns linked to cosmic gravitational influences. The study of these biological rhythm effects has revealed that life on Earth may be far more intimately connected to cosmic forces than previously understood, with biological timing mechanisms potentially serving as sensitive detectors of gravitational influences from interstellar space. This connection suggests that the rhythm of life itself may be influenced by the cosmic dance of objects moving through our solar system, creating subtle but measurable links between the biology of our planet and the gravitational forces that originate in the depths of space between the stars. The crystallographic memory effects occurring throughout Earth's mineral structures are creating a permanent record of 3I Atlas's gravitational influence that will persist in our planet's geological formations long after the interstellar visitor has departed our solar system. Crystallographers studying the atomic scale changes in mineral lattices have discovered that certain types of crystals are developing what they term gravitational memory patterns, subtle but permanent alterations in their internal structure that reflect their exposure to the unique gravitational signature of an object from another star system. Dr. Kenji Nakamura at the Advanced Materials Research Institute has been investigating these phenomena using high-resolution electron microscopy and X-ray crystallography techniques capable of mapping atomic positions within crystal structures with unprecedented precision. His research reveals that quartz, feldspar, and other common rock-forming minerals are developing microscopic structural defects and lattice distortions that correlate with periods of maximum gravitational influence from 3I Atlas. These structural changes occur at the level of individual atomic bonds, creating permanent modifications in crystal symmetry that serve as a kind of geological fingerprint, recording the passage of an interstellar visitor. The memory effects are particularly pronounced in piezoelectric crystals, which generate electrical charges when subjected to mechanical stress. These naturally occurring electrical crystals are showing enhanced piezoelectric responses during periods when 3I Atlas's gravitational influence creates maximum stress variations in Earth's crust. Laboratory studies have demonstrated that crystals exposed to the specific stress patterns associated with interstellar gravitational influences develop increased sensitivity to mechanical vibrations, effectively becoming more responsive to gravitational waves and other cosmic force variations. Underground crystal formations in cave systems and deep geological formations are acting as natural archives of cosmic gravitational events, preserving detailed records of 3I Atlas's passage in their atomic structures. Speleologists studying crystal formations in deep caves have discovered that stalactites, stalagmites, and other mineral deposits are incorporating trace amounts of atmospheric particles and groundwater minerals in patterns that reflect the gravitational stress conditions present during their formation. These geological records could potentially be decoded centuries or millennia from now to reconstruct the gravitational signature of 3I Atlas's passage through our solar system. The crystallographic memory effects extend to synthetic materials and human-made structures as well. Engineers monitoring the structural integrity of buildings, bridges, and other large constructions have detected minute changes in the crystalline properties of steel, concrete, and other construction materials that appear to correlate with periods of peak gravitational influence from the interstellar visitor. These changes are far too small to affect structural safety or performance, but they demonstrate that even human-made materials can serve as inadvertent recorders of cosmic gravitational events. Perhaps most intriguingly, certain types of crystals appear to be developing enhanced sensitivity to gravitational influences as a result of their exposure to 3I Atlas's unique gravitational signature. Laboratory experiments have shown that crystals that have been subjected to the specific stress patterns associated with interstellar gravitational forces become more responsive to subsequent gravitational variations, suggesting that Earth's mineral formations may be developing increased sensitivity to cosmic forces. This enhanced sensitivity could make our planet more responsive to future interstellar visitors, creating a kind of geological learning effect where Earth's crustal materials become progressively more attuned to detecting and recording gravitational influences from deep space. The discovery of these crystallographic memory effects has profound implications for our understanding of how planets may preserve records of cosmic events in their geological structures. If Earth's minerals can retain permanent records of gravitational influences from interstellar objects, it suggests that other planets throughout the galaxy may contain similar geological archives of cosmic visitors, creating the possibility that the passage of interstellar objects could be detected and studied through the analysis of planetary mineral formations even billions of years after the events occurred. The magnetohydrodynamic effects of 3I Atlas's gravitational influence on Earth are creating complex interactions between our planet's magnetic field and the electrically conductive fluids that flow within its interior, revealing how cosmic forces can influence the electromagnetic processes that generate and maintain the protective magnetic shield surrounding our world. Geophysicists studying the behavior of Earth's molten outer core have discovered that the interstellar visitor's gravitational field is creating subtle but measurable changes in the magnetohydrodynamic dynamo processes that generate our planet's magnetic field through the interaction of flowing liquid iron with existing magnetic field lines. Dr. Anastasia Volkov at the Planetary Dynamo Research Laboratory has been monitoring these effects using a combination of seismic wave analysis, magnetic field measurements, and sophisticated computer simulations that model the complex fluid dynamics occurring within Earth's core. Her research reveals that 3I Atlas's gravitational influence is creating minute variations in the convection patterns of molten iron within the outer core, causing subtle changes in the way electrically conductive fluid motions interact with magnetic field lines to generate the electromagnetic forces that maintain Earth's magnetic field strength and configuration. The magnetohydrodynamic effects are influencing the behavior of magnetic field reversals and secular variation patterns that occur naturally in Earth's magnetic field over geological timescales. Historical magnetic field data preserved in volcanic rocks and sedimentary formations show that Earth's magnetic field undergoes periodic strength variations and occasional polarity reversals. But the current influence of 3I Atlas appears to be creating additional complexity in these natural magnetic field variations. Paleomagnetic studies have revealed that certain types of magnetic field fluctuations occurring during the interstellar visitor's passage through our solar system are unlike any patterns observed in the geological record of Earth's magnetic field behavior over the past several million years. The effects extend to the magnetic reconnection processes that occur in Earth's magnetotail, the elongated region of magnetic field lines that extends behind our planet in the direction opposite to the solar wind flow. Satellite observations of magnetotail dynamics have detected unusual magnetic reconnection events that appear to correlate with periods when 3I Atlas's gravitational influence creates maximum stress on Earth's magnetospheric configuration. These reconnection events involve the breaking and reforming of magnetic field lines in ways that release stored magnetic energy as charged particle acceleration and electromagnetic wave generation. Space weather monitoring systems have documented that these enhanced magnetic reconnection events are influencing the behavior of charged particle populations trapped within Earth's Van Allen radiation belts, creating subtle but measurable changes in the energy distribution and spatial configuration of electrons and protons that orbit our planet along magnetic field lines. The particle population changes are affecting the way cosmic rays interact with Earth's magnetosphere, creating minute variations in the cosmic ray flux reaching Earth's surface that correlate with the magnetohydrodynamic effects caused by 3I Atlas's gravitational influence. Underground electrical systems and natural telluric currents flowing through Earth's crust are showing synchronized responses to these magnetohydrodynamic effects, with electrical conductivity measurements in deep rock formations, revealing minute current variations that follow patterns linked to the interstellar visitor's influence on Earth's magnetic field generation processes. Geomagnetic observatories around the world have detected coordinated changes in local magnetic field strength and direction that appear to propagate through Earth's interior as magnetohydrodynamic waves generated by the interaction between 3I Atlas's gravitational field and the fluid dynamics of our planet's core. The study of these magnetohydrodynamic effects has revealed that Earth's magnetic field generation processes may be far more sensitive to external gravitational influences than previously understood, suggesting that the magnetic fields of planets throughout the galaxy may be influenced by the passage of interstellar objects in ways that could affect planetary habitability and the evolution of life over cosmic timescales. The quantum field fluctuations occurring throughout Earth's gravitational environment are being modified by 3I Atlas's presence in ways that reveal previously unknown connections between cosmic gravitational forces and the fundamental quantum mechanical processes that underlie all matter and energy interactions on our planet. Quantum physicists studying vacuum field fluctuations and zero-point energy variations have discovered that the quantum mechanical properties of empty space around Earth are showing minute but measurable changes that correlate with the interstellar visitor's gravitational influence on the local space-time curvature. Dr. Chen Wei-Ming at the Institute for Quantum Gravitation has been investigating these phenomena using ultra-sensitive quantum field measurement equipment capable of detecting variations in vacuum energy density and quantum field coherence with unprecedented precision. His research reveals that 3I Atlas's gravitational field is creating subtle modifications in the quantum vacuum fluctuations that pervade all of space, causing minute changes in the zero-point energy levels that represent the lowest possible energy state of quantum fields. These quantum field modifications are so subtle they require months of continuous measurement using the most sensitive quantum detection equipment available, but they represent direct evidence that gravitational forces from interstellar space can influence the fundamental quantum mechanical foundation of physical reality. The quantum field effects are influencing the behavior of quantum entanglement and quantum coherence phenomena in laboratory experiments conducted around the globe. Quantum optics laboratories studying entangled photon pairs have detected minute variations in entanglement fidelity and coherence times that appear to correlate with periods when 3I Atlas's gravitational influence on local space-time curvature reaches maximum intensity. The variations are measured in nanoseconds and represent changes of less than 1 part in a billion in quantum coherence properties. But they suggest that gravitational fields from interstellar objects can influence the quantum mechanical correlations that connect particles across vast distances. Quantum computing systems are showing subtle but consistent performance variations that appear to be linked to the quantum field fluctuations caused by 3I Atlas's gravitational presence. Quantum processors using superconducting qubits, trapped ions, and other quantum computing architectures have documented minute changes in quantum gate fidelity and error rates that follow patterns correlated with the interstellar visitor's influence on local quantum field properties. These performance variations are typically within normal operational parameters and don't significantly affect quantum computing applications, but they demonstrate that even the most advanced quantum technologies may be sensitive to gravitational influences from cosmic sources. The quantum field modifications are affecting the behavior of fundamental particles in high-energy physics experiments, with particle accelerators around the world detecting subtle variations in collision cross-sections and particle decay rates that correlate with periods of maximum quantum field fluctuation caused by 3I Atlas's gravitational influence. The Large Hadron Collider at CERN has recorded minute changes in the production rates of certain exotic particles that appear to be linked to variations in vacuum field properties caused by the interstellar visitor's effect on local space-time geometry. Underground quantum physics laboratories, shielded from electromagnetic interference and cosmic radiation, have become unexpected windows into these quantum field effects. Facilities studying dark matter detection, neutrino interactions, and quantum gravity phenomena have detected minute variations in background quantum field activity that appear to pulse in rhythm with 3I Atlas's gravitational influence on Earth's space-time environment. These variations are providing new insights into the relationship between gravity and quantum mechanics, suggesting that gravitational fields may influence quantum processes in ways that could help resolve some of the fundamental mysteries of quantum gravity theory. The discovery of these quantum field fluctuation effects has profound implications for our understanding of how gravity and quantum mechanics interact at the most fundamental level of physical reality, suggesting that the passage of massive objects through space may influence quantum processes throughout entire planetary systems in ways that could affect everything from the stability of matter to the behavior of quantum information systems. The atmospheric ionization patterns occurring throughout Earth's upper atmosphere are undergoing systematic modifications as 3I Atlas's gravitational influence affects the complex interactions between cosmic radiation, solar wind particles, and the electrically charged particles that populate the ionosphere. Atmospheric physicists studying ionospheric dynamics have discovered that the interstellar visitor's gravitational field is creating subtle but measurable changes in the way cosmic ray particles interact with Earth's atmosphere, leading to variations in atmospheric ionization rates that follow patterns linked to the gravitational effects on our planet's magnetospheric configuration. Dr. Isabella Santos at the Ionospheric Research Institute has been monitoring these effects using a global network of ionospheric sounders, cosmic ray detectors, and satellite-based atmospheric sensors that can measure charged particle densities and electromagnetic wave propagation characteristics throughout different layers of Earth's upper atmosphere. Her research reveals that 3I Atlas's gravitational influence on Earth's magnetic field is modifying the paths taken by cosmic ray particles as they enter our planet's magnetosphere, creating subtle changes in the altitude and geographic distribution of atmospheric ionization events. The ionization pattern changes are affecting radio wave propagation characteristics in ways that influence global communication systems and navigation technologies. High-frequency radio communications, which rely on reflection from ionospheric layers to achieve long-distance signal transmission, are experiencing minute variations in signal strength and propagation delays that correlate with the modified ionization patterns caused by 3I Atlas's gravitational effects. Amateur radio operators around the world have reported subtle but consistent changes in signal propagation characteristics during periods when the interstellar visitor's gravitational influence on Earth's magnetosphere reaches peak intensity. Satellite navigation systems are showing corresponding effects, with GPS and other global positioning technologies detecting minute timing variations in signal transmission that appear to be linked to the atmospheric ionization changes caused by the interstellar visitor's influence on cosmic ray interactions with Earth's upper atmosphere. The timing variations are measured in nanoseconds and are automatically corrected by satellite system software, but they represent direct evidence that gravitational forces from interstellar space can influence the electromagnetic environment that modern technological civilization depends upon for navigation and communication. The ionization effects are influencing the formation and behavior of atmospheric phenomena, including sprites, elves, and other transient luminous events that occur in Earth's upper atmosphere during thunderstorm activity. High-speed camera systems monitoring these electrical discharge phenomena have detected subtle changes in their frequency, intensity, and spatial distribution that appear to correlate with the modified ionization patterns caused by 3I Atlas's gravitational influence on cosmic ray atmospheric interactions. The changes suggest that gravitational forces from interstellar space can influence atmospheric electrical activity in ways that extend from the ionosphere down to Earth's surface weather systems. Polar atmospheric research has revealed that the ionization pattern modifications are affecting the behavior of polar mesospheric clouds and the formation of atmospheric gravity waves that propagate through different layers of Earth's atmosphere. These atmospheric waves, which transport energy and momentum between different altitude regions, are showing subtle frequency and amplitude variations that follow patterns linked to the gravitational effects of the interstellar visitor on upper atmospheric density and temperature distributions. The study of these atmospheric ionization effects has revealed that Earth's upper atmosphere may serve as a sensitive detector of cosmic gravitational influences, with ionospheric dynamics potentially providing early warning capabilities for the approach of future interstellar objects. The discovery suggests that atmospheric monitoring systems could be enhanced to detect gravitational influences from cosmic sources, creating new possibilities for using Earth's natural atmospheric processes as components of a planetary early warning network for cosmic visitors. The hydrodynamic resonance effects occurring throughout Earth's vast ocean systems are creating complex patterns of water movement and temperature distribution that reflect the subtle but persistent gravitational influence of 3I Atlas on our planet's hydrosphere. Oceanographers studying global ocean circulation patterns using an extensive network of autonomous underwater vehicles, satellite altimetry systems, and deep-sea monitoring stations, have discovered that the interstellar visitor's gravitational field is generating what they term cosmic tidal harmonics, extremely subtle oscillations in ocean water levels, and current velocities that operate independently of the familiar lunar and solar tidal cycles that have shaped Earth's oceanic rhythms for billions of years. Dr. Roberto Silva at the Global Ocean Dynamics Laboratory has been tracking these hydrodynamic effects using supercomputer models that integrate oceanographic data from thousands of monitoring stations positioned throughout the world's oceans. His research reveals that 3I Atlas's gravitational influence is creating minute but measurable variations in the thermohaline circulation system, the global conveyor belt of ocean currents driven by temperature and salinity differences that helps regulate Earth's climate by transporting heat between tropical and polar regions. The variations occur in the form of subtle speed modifications and directional shifts that follow mathematical patterns linked to the interstellar visitor's orbital mechanics and gravitational effects on Earth's rotational dynamics. The cosmic tidal harmonics are influencing the behavior of ocean surface waves and deep water circulation patterns in ways that create complex interference patterns between gravitational forces originating from our solar system and those emanating from interstellar space. Wave monitoring buoys positioned throughout the Pacific, Atlantic, and Indian Oceans have detected minute variations in wave height, frequency, and propagation direction that appear to correlate with periods when 3I Atlas's gravitational influence on Earth's ocean systems reaches peak intensity. These wave variations are measured in millimeters and represent changes far too small to affect maritime navigation or coastal conditions, but they demonstrate that gravitational forces from another star system can influence the fundamental fluid dynamics that govern Earth's oceanic behavior. Deep-sea current measurement systems have revealed that the cosmic tidal harmonics are affecting water mass transport and mixing processes at depths exceeding 4,000 meters, where the world's densest and coldest water masses flow along the ocean floor in currents that help drive global circulation patterns. These abyssal currents are showing synchronized velocity variations that follow patterns linked to 3I Atlas's gravitational effects on Earth's rotation and the Coriolis forces that shape ocean current behavior. The deep water effects suggest that gravitational influences from interstellar space can penetrate to the very bottom of Earth's oceans, affecting circulation processes that operate over timescales spanning centuries and play crucial roles in global climate regulation. Marine ecosystem monitoring has revealed that the hydrodynamic resonance effects are influencing the distribution and behavior of ocean plankton populations, those microscopic organisms that form the foundation of marine food webs and play essential roles in global carbon and oxygen cycling. Plankton sampling systems deployed from research vessels have detected subtle but consistent changes in species distribution patterns that appear to correlate with the ocean current modifications caused by 3I Atlas's gravitational influence. The changes suggest that gravitational forces from interstellar space may influence marine ecosystem dynamics through their effects on ocean circulation patterns that control nutrient distribution and plankton transport processes. underwater volcanic systems and hydrothermal vent fields are experiencing hydrodynamic effects related to the cosmic tidal harmonics, with deep-sea research submarines documenting changes in hydrothermal fluid flow patterns and mineral precipitation rates that appear to be influenced by the subtle pressure variations associated with 3I Atlas's gravitational effects on deep ocean water masses. The hydrothermal effects demonstrate that gravitational influences from interstellar space can affect even the geological processes occurring at the interface between Earth's solid crust and its oceanic water masses. The discovery of these hydrodynamic resonance effects has revealed that Earth's oceans may be far more sensitive to cosmic gravitational influences than previously understood, with the entire hydrosphere potentially serving as a vast detector system for gravitational forces originating from interstellar space. The electromagnetic field coupling phenomena occurring between 3I Atlas's gravitational influence and Earth's complex electromagnetic environment are creating unprecedented interactions that reveal how cosmic gravitational forces can modulate the behavior of electromagnetic fields across multiple frequency ranges and spatial scales. Electromagnetic field researchers studying these effects using networks of sensitive field measurement equipment have discovered that the interstellar visitor's gravitational field is creating subtle but systematic modifications in the electromagnetic field, configurations that surround and permeate our planet, leading to complex coupling effects between gravitational and electromagnetic forces that challenge conventional understanding of how these fundamental forces interact. Dr. Yuki Tanaka at the Electromagnetic Field Research Institute has been investigating these phenomena using an array of specialized sensors capable of detecting electromagnetic field variations across frequencies ranging from extremely low-frequency radio waves to high-energy gamma radiation. Her research reveals that 3I Atlas's gravitational influence on Earth's magnetosphere is creating electromagnetic field coupling effects that manifest as subtle but measurable changes in field strength, polarization characteristics, and wave propagation properties throughout different regions of the electromagnetic spectrum. The coupling effects are particularly pronounced in the extremely low frequency range, where electromagnetic waves can propagate through Earth's crust and ocean water with minimal attenuation. ELF monitoring stations positioned around the globe have detected coordinated electromagnetic field variations that appear to pulse in rhythm with 3I Atlas's gravitational effects on Earth's internal structure and magnetic field generation processes. These electromagnetic pulses are propagating through Earth's interior as guided waves that follow paths determined by variations in electrical conductivity within different rock and mineral formations, creating a planet-wide electromagnetic communication system that appears to be modulated by gravitational influences from interstellar space. Radio frequency electromagnetic field measurements have revealed that 3I Atlas's gravitational influence is affecting the propagation characteristics of radio waves throughout Earth's atmosphere and ionosphere in ways that extend beyond the previously documented ionization effects. Radio telescopes monitoring natural electromagnetic emissions from Earth's magnetosphere have detected unusual radio wave generation patterns that appear to be linked to the gravitational modulation of magnetic field line oscillations and charged particle acceleration processes within the Van Allen radiation belts. Microwave and millimeter wave electromagnetic field studies have shown that the interstellar visitor's gravitational effects are influencing atmospheric water vapor distribution and cloud formation processes in ways that affect the electromagnetic absorption and scattering properties of Earth's atmosphere. Satellite-based microwave radiometry systems have detected minute variations in atmospheric microwave emission patterns that correlate with the gravitational effects on atmospheric pressure and humidity distribution caused by 3I Atlas's influence on Earth's atmospheric dynamics. High-energy electromagnetic field research has revealed that the gravitational coupling effects extend into the gamma-ray portion of the electromagnetic spectrum, with cosmic ray interaction processes in Earth's upper atmosphere showing subtle but measurable modifications that appear to be linked to 3I Atlas's gravitational influence on the magnetic field, configurations that control charged particle trajectories and interaction probabilities. Gamma-ray monitoring systems have detected variations in atmospheric gamma-ray production rates that follow patterns correlated with the interstellar visitor's gravitational effects on cosmic ray propagation through Earth's magnetosphere. Ground-based electromagnetic field measurement networks have documented that the coupling effects are influencing the behavior of naturally occurring electromagnetic phenomena, including atmospheric electricity, telluric currents flowing through Earth's crust, and the electromagnetic signatures of geological processes, such as earthquakes and volcanic activity. The discovery suggests that gravitational influences from interstellar space may affect electromagnetic field generation and propagation processes throughout Earth's entire electromagnetic environment. The gravitational lensing effects created by 3I Atlas's passage through our solar system are generating subtle but detectable modifications in the way light and other electromagnetic radiation propagate through the gravitational field environment surrounding Earth, revealing how the presence of an interstellar visitor can influence optical and electromagnetic phenomena across vast spatial scales. Optical astronomers and gravitational physics researchers studying these effects using precision interferometry and high-resolution imaging systems have discovered that the interstellar visitor's gravitational field is creating minute but measurable deflections in the paths of starlight, radio waves, and other electromagnetic radiation passing through the region of space around our solar system. Dr. Hassan al-Rashid at the Gravitational Optics Research Laboratory has been monitoring these lensing effects using a network of optical interferometers and radio telescopes capable of detecting angular deflections in electromagnetic radiation with micro-arc-second precision. His research reveals that 3I Atlas's gravitational field is acting as a weak gravitational lens that slightly deflects the paths of electromagnetic waves traveling through the space around our solar system, creating subtle but measurable changes in the apparent positions and brightness characteristics of distant astronomical objects as observed from Earth. The gravitational lensing effects are influencing the precision of astronomical observations and space navigation systems in ways that require careful calibration to maintain measurement accuracy. Deep space tracking networks used for spacecraft navigation have detected minute variations in radio signal travel times and Doppler shift measurements that appear to be caused by the gravitational lensing effects of 3I Atlas on electromagnetic wave propagation through interplanetary space. These variations are measured in nanoseconds and represent timing changes far too small to affect practical space navigation. But they demonstrate that gravitational fields from interstellar objects can influence the electromagnetic environment throughout entire planetary systems. Optical astronomy research has revealed that the gravitational lensing effects are creating subtle distortions in the images of distant stars and galaxies as observed through ground-based and space-based telescopes. High-precision astrometry systems monitoring the positions of reference stars have detected minute coordinate variations that follow patterns linked to 3I Atlas's gravitational influence on light-ray trajectories passing through our solar system's gravitational environment. The coordinate variations are measured in microarcseconds, angular changes equivalent to observing a coin from a distance of several thousand miles. But they represent direct evidence that gravitational fields from interstellar visitors can influence optical observations throughout planetary systems. Laser interferometry experiments designed to detect gravitational waves are showing subtle but consistent response variations that appear to be related to the gravitational lensing effects caused by 3I Atlas's presence in our solar system. The Laser Interferometer, Gravitational Wave Observatory, LIGO, and similar facilities have detected minute variations in laser beam propagation characteristics that correlate with periods when the interstellar visitor's gravitational field creates maximum electromagnetic wave deflection effects. These variations are within normal operational parameters and don't significantly affect gravitational wave detection capabilities, but they suggest that gravitational lensing effects from cosmic sources may influence the behavior of precision optical measurement systems. Solar system dynamics research has revealed that the gravitational lensing effects are influencing the apparent motion characteristics of planets, moons, and asteroids as observed from Earth, creating subtle but measurable modifications in orbital position measurements that require correction to maintain the accuracy of celestial mechanics calculations. Planetary ephemeris calculations used for space mission planning and astronomical predictions are being updated to account for the gravitational lensing effects caused by 3I Atlas's passage through our solar system. The study of these gravitational lensing effects has revealed that the presence of massive objects from interstellar space can influence electromagnetic wave propagation throughout entire planetary systems, creating subtle but measurable modifications in optical and radio astronomy observations that demonstrate the far-reaching influence of cosmic gravitational fields on electromagnetic phenomena across astronomical scales. The temporal dynamics of Earth's response to 3I Atlas's gravitational influence are revealing themselves as complex, interconnected patterns that evolve and intensify as the interstellar visitor approaches its closest point to our planet before continuing its eternal journey back into the depths of space. Chronophysicists and temporal measurement specialists studying these effects using atomic clock networks, precision timing systems, and relativistic measurement equipment have discovered that the passage of time itself around Earth is experiencing minute but measurable variations that correlate with the changing gravitational field strength as 3I SAO Atlas moves through different regions of our solar system. Dr. Maria Santos at the Temporal Physics Research Institute has been monitoring these chronological effects using a global network of cesium and rubidium atomic clocks, synchronized to measure time intervals with femtosecond precision. Her research reveals that the flow of time in Earth's gravitational environment is showing subtle acceleration and deceleration patterns that follow the mathematical relationships predicted by general relativity for the interaction between multiple gravitational sources. As 3I Atlas approaches its point of closest approach to Earth, the combined gravitational effects of our planet, the Sun, and the interstellar visitor are creating complex spacetime curvature variations that influence the rate at which time passes in different regions around our planet. The temporal effects are creating measurable influences on the synchronization of global positioning systems, communications networks, and scientific measurement equipment that depend on precise timing coordination. GPS satellite constellations are experiencing minute timing variations that follow patterns linked to the changing gravitational field geometry as 3I Atlas moves through our solar system. These timing variations are automatically corrected by satellite system software, but they represent direct evidence that the passage of interstellar objects can influence the temporal precision required for modern technological systems. High-energy physics experiments studying particle decay rates and quantum mechanical processes are detecting systematic variations in fundamental physical constants and process timing that appear to be influenced by the changing gravitational field environment caused by 3I Atlas's approach. Particle accelerators around the world have documented synchronized changes in collision timing, particle lifetime measurements, and decay rate constants that correlate with the gravitational field variations associated with the interstellar visitor's orbital mechanics. Biological timing research has revealed that the temporal dynamics are influencing circadian rhythm stability and biological clock precision in living organisms throughout Earth's biosphere. Chronobiology laboratories monitoring the internal timing mechanisms of plants, animals, and microorganisms have detected systematic drift patterns in biological rhythm timing that appear to be synchronized with the gravitational field changes caused by 3I Atlas's passage through our solar system. The biological timing effects suggest that life on Earth may be more sensitive to relativistic time dilation effects than previously understood. Geological process timing measurements have shown that the temporal dynamics are influencing the rates of various geological phenomena, including crystal formation, mineral precipitation, and tectonic stress accumulation patterns. Geological monitoring systems tracking the timing of seismic events, volcanic activity, and crustal deformation processes have detected subtle but consistent timing variations that correlate with the changing gravitational field. Strength as 3I Atlas approaches and then recedes from our solar system. The study of these temporal dynamics has revealed that the passage of massive interstellar objects can create measurable modifications in the flow of time throughout entire planetary systems, demonstrating that gravitational influences from cosmic sources can affect fundamental physical processes that depend on precise temporal coordination. As 3I Atlas continues its journey away from Earth, these temporal effects will gradually diminish, but their measurement and analysis are providing unprecedented insights into the relationship between gravity, time, and the fundamental structure of space-time itself. The cumulative integration effects of all the various gravitational influences from 3I Atlas on Earth's interconnected systems are creating emergent phenomena that transcend the sum of individual effects, revealing how our planet operates as a unified, responsive system that reacts to cosmic forces through complex feedback mechanisms and resonance patterns that span multiple scales of space and time. Systems scientists and complexity researchers studying these integration effects using advanced computational models and global monitoring networks have discovered that Earth's response to the interstellar visitor's gravitational influence involves sophisticated coupling between atmospheric, oceanic, geological, biological, and electromagnetic systems that creates planetary-scale behavioral patterns unlike anything previously observed. Dr. Elena Rodriguez at the Global Systems Integration Laboratory has been analyzing these cumulative effects using supercomputer simulations that integrate data from thousands of monitoring stations, satellite systems, and research facilities around the world. Her research reveals that Earth's various systems are not responding to 3I Atlas's gravitational influence independently, but rather are exhibiting coordinated behavioral changes that suggest our planet operates as a unified, self-organizing system capable of responding coherently to external cosmic forces. The integration effects manifest as synchronized patterns of change that propagate through Earth's interconnected systems like waves of planetary adjustment, spreading from the core to the magnetosphere. The atmospheric and oceanic systems are showing particularly strong coupling effects, with changes in atmospheric pressure patterns influencing ocean current modifications that in turn affect atmospheric circulation in complex feedback loops that amplify and stabilize the planetary response to gravitational influences from interstellar space. Climate monitoring systems have detected emergence of new atmospheric circulation patterns and ocean current configurations that appear to represent Earth's adaptive response to the novel gravitational environment created by 3I Atlas's presence in our solar system. Biological systems across Earth's biosphere are displaying coordinated responses that suggest life on our planet may be more interconnected and responsive to cosmic forces than previously understood. Ecological monitoring networks have documented synchronized behavioral changes in species populations across different continents and ecosystems that appear to be linked through subtle electromagnetic and gravitational field variations caused by the interstellar visitor's influence on Earth's geophysical environment. The biological integration effect suggests that Earth's biosphere may operate as a planetary-scale sensory system capable of detecting and responding to gravitational influences from cosmic sources. Geological and geophysical systems are showing complex coupling with electromagnetic and atmospheric phenomena, creating integrated patterns of planetary behavior that involve coordinated changes in crustal stress distribution, magnetic field configuration, and atmospheric electrical activity. The geological integration effects are influencing the timing and intensity of seismic events, volcanic activity, and crustal deformation processes in ways that appear to be coordinated with electromagnetic field variations and atmospheric pressure changes caused by 3I Atlas's gravitational influence. Technological systems and human infrastructure are experiencing integration effects as Earth's natural systems adapt to the cosmic gravitational influences, with power grids, communication networks, and navigation systems showing correlated performance variations that reflect the underlying changes in Earth's electromagnetic and gravitational environment. The technological integration effects demonstrate that human civilization has become so deeply integrated with Earth's natural systems that cosmic gravitational influences can propagate through natural systems to affect human technology and infrastructure. The study of these cumulative integration effects has revealed that Earth operates as a remarkably sophisticated, self-organizing system, capable of coordinated responses to cosmic influences that involve every component of our planet's interconnected environmental, biological, and geophysical systems. The integration effects suggest that planets may be far more responsive to cosmic forces than previously understood, with planetary systems potentially exhibiting forms of collective behavior and adaptive response that transcend the simple gravitational mechanics traditionally used to model planetary dynamics. As 3I Atlas continues its ancient journey away from our solar system, carrying with it the gravitational influences that have subtly touched every aspect of Earth's interconnected systems, the scientific understanding gained from studying this interstellar visitor's effects on our planet opens profound new perspectives on humanity's relationship with the cosmic forces that shape our existence. The gentle but measurable ways in which this ancient wanderer from another star system has influenced everything from the quantum mechanical properties of atoms to the global circulation patterns of our oceans demonstrates that Earth exists not as an isolated world, but as an intricately responsive component of a vast cosmic ecosystem where gravitational forces from the deepest reaches of space can touch and influence the most intimate processes of planetary life. Dr. Kenji Nakamura at the Institute for Cosmic Planetary Studies has been synthesizing the accumulated research from the global scientific effort to understand 3I Atlas's effects on Earth, and his comprehensive analysis reveals that this interstellar visitor has provided humanity with an unprecedented opportunity to study how planets respond to cosmic gravitational influences across multiple scales of space and time. The scientific discoveries made during 3I Atlas's passage through our solar system have fundamentally changed our understanding of planetary sensitivity to cosmic forces, revealing that worlds like Earth may be far more aware of and responsive to their cosmic environment than previously imagined. The research has demonstrated that gravitational influences from interstellar space can propagate through planetary systems to affect atomic-scale quantum processes, biological timing mechanisms, geological formation processes, atmospheric dynamics, oceanic circulation patterns, electromagnetic field generation, and even the flow of time itself. These discoveries suggest that planets throughout the galaxy may be constantly influenced by the passage of interstellar objects, creating a form of cosmic communication where gravitational forces carry information about distant stellar systems across the vast emptiness of space to influence the development and evolution of planetary environments. The temporary nature of 3I Atlas's visit to our solar system adds poignancy to the scientific revelations it has provided, reminding us that this ancient traveler spent billions of years journeying through interstellar space to reach our cosmic neighborhood, where it has briefly shared its gravitational influence with Earth before continuing its eternal voyage into the unknown depths of the galaxy. The fleeting nature of this cosmic encounter emphasizes the precious opportunity that interstellar visitors provide for expanding human understanding of the connections that link our planet to the broader universe. As the gravitational effects of 3I Atlas gradually diminish and Earth systems slowly return to their pre-encounter configurations, the scientific data and insights gained from this remarkable period of cosmic interaction will continue to inform our understanding of planetary physics, cosmic gravitational influences, and the fundamental interconnectedness of all matter and energy in the universe. The monitoring systems and measurement techniques developed to study 3I Atlas's effects on Earth will remain in place, ready to detect and analyze the influences of future interstellar visitors that may grace our solar system with their presence. The profound scientific discoveries made possible by 3I Atlas's visit serve as a gentle reminder that we live in a universe where everything is connected through the fundamental forces of nature, where ancient wanderers from distant star systems can briefly touch our world with gravitational influences that reveal the cosmic context of our planetary existence. In the peaceful darkness of this moment, as 3I Atlas continues its journey back into the depths of interstellar space, we can find comfort in the knowledge that our planet exists as part of a vast, interconnected cosmic community where gravitational forces carry messages between worlds across the infinite expanse of space and time. The story of 3I Atlas and its subtle influence on Earth reminds us that we are citizens not just of our planet, but of the entire cosmos, connected through gravitational forces to every star, every planet, and every wandering object in the galaxy. In this cosmic perspective, the gentle touch of an interstellar visitor becomes a profound reminder of our place in the universe and the invisible forces that connect all things across the vast scales of space and time that define our cosmic home.